All right. Excited to share a project that I worked on with a student today. And honestly, we talked about it. I was feeling stumped. The goal was to make geometry that simulated this spiral crimped fin tube. Um, I kind of figured it was a math um, problem more than a CAD problem, and it left me kind of stumped. We did some searching, couldn't really find any great resources. So um, I love it when I make a resource that I come back to because I need it later. So this takes, this is the image that we're looking to make something that's similar to this. Um, I've got the parametric curve and the define parameter feature scripts that I'm using. And I'm using the document notes here to keep track of how this goes. So rather than build it, we're just going to kind of walk through it. I have a lot of, pretty much everything's been added as a variable. So the radius of the outside of the tube, but the inside of the fin, the wall thickness of the tube, the length of the tube, the extrude, the length is the length of the tube with fins. So here we have 2 inches of tube with fin, and then the extrude makes it that plus an inch on either side. Outer radius of the fin, right? The pitch. So I need to go in and add some kind of if statements on this one, that the pitch needs to finish in clean numbers of patterns for this currently to function properly. So one, maybe it should be the other way where I have it set up to be the number of fins per inch, and then the pitch is calculated from there. Maybe I'll make that change. Anyway, this is the amplitude at the inside of the sign, and this is the amplitude at the outside of the fin. W is how many waves around the outside. And then we have define parameter. So define parameter is way up here, right? Define parameter is a feature script. All you do with this is you just say T is my parameter. And then the parametric curve. So the parametric curve works so much better here if we do it in cylindrical coordinates. So cylindrical, we need R, so the radius around your cylindrical coordinate system. Theta, so theta goes from 360 degrees. That degrees is important. You got to type that degrees in. 360 degrees times the function t. Now here, let's demo this because this is a little frustrating, I guess. 360 degrees times t. Now when I type in t, it comes in as a function and it has the parentheses here. And unfortunately, if I try to accept that the way it is, it doesn't do anything. If I get rid of the parentheses and hit enter, it adds them back in. If I get rid of the parentheses and click somewhere else, then it works. Not sure why it's set up like that. Definitely a point of frustration, but it does work when we do that. Okay, so theta goes from 360 times 0 to t, and then t I run from 0 to not 1 but n, which is how many fins per inch. So if I want 5 inches, I'm going to run t from 0 to 5. Now z is the amplitude of the wave. We're in the z direction. So along the tube here, we've got the pitch times t plus your amplitude times the sine wave, and the wave is how many waves you want around the outside times 360 degrees times the value of t from 0 to 5. So pitch times t will help us travel along the length of the cylinder. So that's what kind of gives it that thread type shape, the spiral. So that is kind of the big takeaway here. And that gets that inner curve that you can see. Waiting. This is a challenging model, so it does take a little bit of time. The outside curve is the parametric curve, right? So we have the outer radius, again, 360 times t, and then the outer z value is p times t plus the amplitude of the outside one times sine times w 360 degrees times t. Very, very similar. We're just using a different outside radius and a different outside amplitude. If you wanted it to be a straight circle on the outside with no wave at all, then you'd get rid of this second portion and you would just use the pitch times the thick times t. Again, going from 0 to n. Number of points, you don't want to have anything, you can't have anything more than 1,000. If I bring it down to a smaller number, this will probably rebuild a little bit quicker. But yeah, get rid of the second half of the z equation if you just want a circle out there. Okay. So with those two equations, here we can show you what it looks like. Right, that's 1 inch. And the boundary surface, they're both U profiles. I select curve 2 and 1, could be 1 and 2. I really don't think it matters. Right, and pretty straightforward, adding this boundary surface, and then just add a wall thickness to the surface. Right, so put the wall thickness in here. I don't have that as a variable. I probably should. I have it along the center of the surface, but you could have it on one side or the other. I have it as its own part so that I can pattern it. Otherwise, you could add it directly to the pipe. Okay. And then the linear pattern. So because I have it as its own part, part 2 here. In fact, you know what? Let's rename that and call that the fin. Okay. Pattern, linear pattern, let's add it. And we're going to take the part pattern, fin. We're going to add these all together, so it's going to add it to itself. The distance is 1 inch, and the instance count is the length that we want with fins divided by inch, because we need it to be an integer. Length is inches, so length wouldn't work, so it has to be length divided by inches. Okay. Pretty psyched that this worked out. I also did it earlier in Creo with the curves from equations using cylindrical coordinates there. So we didn't see a lot of resources available when we were looking, and now we have one. So I hope that helps, and it was a great challenge. Pretty excited to get that figured out. Take care.